Stop. All right. Come on, hush. You're recording, kids. Act like you know something. So anyways, the last thing up there is check for extraneous solutions. Do you remember what extraneous solutions were? Oh, they're real. They're just not, they don't make sense. They're real answers. Don't make sense. Yeah, not practical is a good idea. The reason this shows up, and it's pretty explicit, it only shows up on even roots, is because if somebody asks you what the square root of 16 is, what do you tell them? Tell them it's 4. But what if you're solving for x and it's x squared is 16? Plus or minus. See, what happens here when we counteract some of these radicals is we end up squaring things. That just throws it off and introduces the idea of something happening that shouldn't. But the square root function is only supposed to return positive answers. That's what it's supposed to do. It's only supposed to return positive answers. We graphed the arm yesterday. That thing went up, didn't it? It never went down. The y values were always what? Positive, unless we did a reflection, right? But the root itself is always returning positivity. That can show up. Now this is an odd root. I hope you see that. It's a cubic root. That's odd. I don't need to worry about its roots. Odd roots don't care. The odd root can return a positive or negative depending on what's in it. So it doesn't apply to them. But anyways, the general idea is isolate the radical. Is that radical isolated?
Yeah.
Yes. Yes, it is. It's all by itself. It's like that poor kid lunch.
True.
LJ, what's the opposite of cube rooting? Cubing. Yes, sir. So your next line, or even right there, doesn't really matter where you do it. You just cube both sides. Why both sides? Quality properties. Caitlin, what is that cube going to do to that cube root? Cancel it out. The 3's legit cancel. You might like exponent notation, but the 3's cancel. There's no need for a root now because now the power would be what? 1. There's no need for it there. What's the 1th root? You ever hear of such a thing? I haven't either. 3 cubed, 27, and you ought to be good. 90% of y'all can do that in your head, real quick. What is it? 10. It's 10. You know, on test day, if you can't do this, if you're that kid, and you see answer choices, what could you do with those answer choices? That's how you check your work. Teachers have been teaching you how to game test for a long time. They say, check your work. They're not trying to bore you to death. They're telling you that you can always plug answers in. You plug a 10 in, you end up with a cubic root of what? 27. What is the cubic root of 27? 3. Oh, well, wow. Works. Who would have thought? For some reason, you all get a test in front of you and you forget about little things like that. And you guys have been shown the storage feature. I've graded so many basics quizzes today where the kid didn't use the storage feature. Why not? Not cheating.
Eating your resources.
It's morally cheating.
It's not even morally cheating.
Oh, yeah, I use it.
It isn't moral.
Yeah.
It even said, please use the storage feature, didn't it? Please.
Yeah, I agree.
All right, moving on. C. Is that a radical equation?
Yeah.
It is. That's definitely a radical equation. Why? Power over the root. That's right. You could think of this as the the cubic root of x plus 2 squared. It's definitely a radical equation. So the first step here was to isolate the radical. Turbo, how do you isolate that radical? Did you listen to Austin? You did, didn't you? You listened to Austin, didn't you?
This is Austin. First mom. That's like
Miller, how do you isolate that radical? No. Reed, how do you isolate that radical?
Come on,
Jordan, how do you isolate the radical?
Subtract 3.
Subtract 3, kids.
No, I was like, I wasn't like moving past that. I was like doing like graph.
That's isolation. You guys were still thinking I was gonna rewrite this as a radical equation. I was not. Why would I? It's actually harder to do this with a radical than it is to look at it with exponents. It's supposed to be. Mackay, what's the opposite power of the 2/3?
2/3.
What's the opposite power of 2/3? Twice has been written in your notes. Olivia, what's the opposite of 2/3 power? 3/2. The reciprocal. So maybe, like I said, maybe we need to speak of this again. The opposite power, always the reciprocal. The reciprocal of 2/3 is going to be 3/2 all day long.
Yeah.
Not necessarily the opposite. It's the multiplicative inverse is what it is. It's the multiplicative inverse, because if you multiply these two things together, what understood number do you get? 1. They cancel out to that understood first power. Let's raise this up. So, what's 4 to the 3/2? Is that what your calculator told you? Calculator's an 8, right? Well, let me put it like this. That's the square root of 4, all cubed. You're solving for x. You're solving for x. When you're solving for x, what symbol shows up when you do square roots? Plus or minus, kids.
Oh, I put up
The plus or minus 2 that is cubed. That's what it is. When you're solving for x and you take even roots, you include plus or minus. That one is a plus or minus 2 that is all cubed.
minus 8.
Plus or minus 8. Hold on. You have to go back and look at your notes from last week there, but we talked about that last week. On even roots, what symbols show, how many answers do you have on even roots? 2. There's an even number there, that's the root. Even roots. Have 2 answers. Well, I'm pretty sure that's right. You have a -8 minus a 2, or you have a +8 minus a 2 because of isolation. -10 and? Then they should be checked too. Did you take an even root? Is that an even root?
Yeah.
What's that first slide say about even roots? The possibility of extraneous. So you might need to see how 84 did this, but you need to figure out what -10 plus 2 to the 2/3 plus 3 is. And you also need to figure out what 6 plus 2 to the 2/3 is. Both 7. Not necessarily, of course, one of them can be extraneous. You get something else. It happens. Sometimes you plug things in and you get something else.
Listen, I think my calculator messed up here with test.
And now I'm in the final.
Why?
Because every time I press Z6, it was just like completely take away. Like after I did the window.
You're not supposed to press Zoom 6 after you play with the window. You're supposed to figure out.
Oh, well. I don't know what I was doing, but it
We found the issue.
I have no idea what that has to do with this particular question, but
It don't have nothing to do with this particular question.
you're not supposed to hit Zoom 6 after you play with the window.
Well, it makes me mad.
Well, we found the issue.
All right, we're gonna skip D.
I'm gonna still back.
Gonna do the
Wait, so
easiest.
what's the extraneous?
We haven't run into that situation yet. Did both of those make
So
sense?
they're both,
Yes.
well. it's-
They can have extraneous.
It just says you need to check for them, it doesn't say you'll have them. We're gonna do the easiest one in your notes. Root 2x plus 5 equals root x plus 7. Eva, what would you like to do? No, the deal is radical isolation. Are the radicals isolated?
Yes.
We just square them. Square each side. Because you know what's gonna happen if you square each side. If you square each side, what's the left-hand side gonna become?
Plus 5.
How about the right-hand side?
X plus
Don't you wish they could all be that easy? Yeah, they're not. No, we're not gonna do more on that one. Hope you know the answers too. We'll spend some time on this one.
This will be.
Anyways, I've moved on. You should too. Is our radical isolated on this example?
Yes.
It's always the first step, by the way. Isolate the radical. So, what are we gonna do to both sides? It's the square root.
Square.
Square it. We'll square both sides.
No, Micah, you leave it.
I was gonna call on somebody who might not know. Thank you, Micah.
Sorry.
How do we handle the left-hand side? Write it twice and what? I wrote it twice. I'm gonna go ahead and do the right-hand side. That's easy. What's the right-hand side? 7x plus 15. I'm sure some of you guys by now have foiled left. What'd you get? Square plus 2x plus 1. The number of kids who have missed the third question on that basics quiz is very disturbing to me. Third question was a factoring example and the choices were labeled. Like, it's gotta be 7% of student body missing that one. All you do is foil, isn't it?
Yeah.
I don't understand why it's being missed. That means we can't foil. If you can't foil, do you honestly think you deserve anything other than an F?
I think the eyes must be for
You need to figure that out. You can't foil, find me, I'll help you. Go to YouTube, type in foil. Do I just see somebody, smoking a foil? Or you learn how to do the foil technique? What do you want?
Or just a random video on aluminum foil.
Now, this thing that we've ended up with has x squared, it has x's, and it has numbers. Since late summer, last year, I thought you were doing this. No, earlier, it's quadratic formula. What do you have to do with it initially? Set equal to 0. You got a mixture of all three pieces. You shift things around so that you're equal to 0, and I'm gonna move left. 2x minus 7x minus 5x, 1 minus 15. And your choices here would be to hit it with quadratic formula or factor. Which one?
Will work, yeah, that will work.
It's factors. Are there factors of 14 that add 5? 7 and 2. Factoring is supposed to be quick. Takes an x and an x, create x squared. Factors of 14 are going to be 2 and 7. So that you sum to the negative 5. What? Negative 7, positive 2. And what are your x values? Your x values are x equals 7 and x equals negative 2.
Now do we check for that?
Now you check for strangeness. It'd be nice to kind of wrote it out too, kids. Otherwise, you're just going to have an increased chance of forgetting it. But what do I know? We'll plug in the 7. 7 plus 1 is supposed to be equal to the square root of 7 sevens out of 15. What is 7 sevens out of 15? God, y'all are smart. 64. What is the root of 64? That guy worked, isn't it? What else you need to plug in? Negative 2. There's your plug-in line. Sum of negative 2 and 1. On the right-hand side, you end up with the root of 1. And what is the root of 1? True or false? False. That means that guy is extraneous. Something they all are guilty of, it happens in two particular examples. One, kids don't like to plug in and check their work, ever, which I understand. And you really screwed up on this one. Well, I've already erased it. But there was that problem, there was plus or minus, right? You realize you have a TI-84 graphing calculator in front of you? TI-84 can show you a lot of things. It can show you real answers for one, things that actually work. So I'm going to graph the original equation that we had here. You should too. Same one. Same one we just did. You should too. Some of y'all can't graph yet. Daniel's apparently.
I know.
I was one of them.
I know, right?
Of course it's an arm, it's a square root. You should see a line and an arm intersect. Shouldn't you? X plus 1's a line, y 1's an arm. So if you're a kid who doesn't like to plug in, and you'll see this, like the state of Tennessee, when they give you your end of course test, they will ask you questions like, what is the real solution of this equation?
Good afternoon. Just a couple announcements. Reminder, no school on Monday. So take the weekend off and enjoy a 3-day weekend. Basketball game tonight is at Bradford, tip-off 6 p.m. Also, get a chance today to see Miss Abbott in the hall. Congratulate her for being the district teacher of the year. Have a great afternoon.
Huh?
So I should have went to you.
I've been there a couple times. So, anyways, back to this. The state of Tennessee, and I said the wording wrong, the state of Tennessee will sometimes ask you only what the extraneous answer thing is, which means you actually have to do the algebra. All right? Because there's no way to get an extraneous answer unless you do algebra. But you can get real answers either by doing algebra or looking at graphs. All right? Now, we decided that negative 2 didn't make sense, so I'm going to do my zoom 6 here. And we're going to see the arm and the line intersect. And what you should see is you should see an intersection right around where x is 7, right? Do you see an intersection where x is negative 2? Why not? It was extraneous. So keep that in mind. Your real calculator can give you real things, things that make sense, but what can't it give you? It can't give you imaginary, can't give you extraneous. It's the thing it can't do. Anyways, that's it for notes. You got lots of stuff to keep you busy.